Okay, so I'm starting now. So yesterday, let's just revise what we just did. So we started with a new topic, collection framework. So what is these are two different terms, collection and framework. So collection is, you can say in your simplest words, it's a group of elements or objects. That's what collection represents. Even general language in real life, if you say collection, that means we're talking about some group of elements or objects or items. Same way, it's a collection. It's that's the same thing here, collection. Framework is something which provides some built-in solutions. So we have lots of frameworks out there. If we talk about Java, we have certain frameworks like struts, hibernate, spring framework, spring boot, part of spring framework. So all these are frameworks. So why we use these frameworks? Because they give us some built-in solutions. We don't have to write everything from the scratch. They give us a structure, and we by using or expanding the structure we can write our code. So by using collection framework we will see how much efficient it is and how many inbuilt solution it provides in terms of data structures. In data structure, we have list, arrays, trees, maps, binary search, sortings mechanism. All these are really, I would say, for a beginner to mediator guys, even for sometimes experienced guys, they're hard to understand what's happening there. So what Java guys did, they created a whole collection framework and gave the solution. So we have lots of classes out there like this. So all these classes provide some inbuilt solutions. So we talked about collection interface, list, array list, and yeah, we are done, almost done with the stuffs. Next, we have to see we'll continue the same part. So yesterday we talked about attribute interface, that's the parent of all classes. Then usually collection interface is known as a root interface or the root class, which act as a parent class or interface. Then we saw by functionality wise or by feature wise, multiple interfaces has been introduced: list, queue, dequeue, set. Then we talked about list interface, which gives us index based approach. We can mention index and it entertains duplicate elements. So same functionality was followed by array list. Then we talked about set interface, and set has one unique functionality, that it doesn't allow duplicate elements. And since set is an interface, you cannot create instance, so we tried to create object of HashSet, and there we implemented lots of features and we tested multiple methods coming from the collection interface. So today we will see linked HashSet. Okay, so yesterday I gave you idea like how things works. If you have to understand any class, linked HashSet, and type this Java doc. So Oracle provides its official documentation. So if you have any idea or not sure how this class works, what's the behavior, so you can always open its documentation. So we are talking about linked HashSet this time. Linked HashSet class. This is a class. Oh, HashSet. That's a Java class, and this is its class signature. So public class linked HashSet, then it extends HashSet, that's a parent of this class, and it implements set interface, clonable and serializable. That's its class signature. Okay. Okay, just remind one thing before proceeding with the example. I have to explain one more thing here. Yesterday we saw these yellow warnings when we execute this code. How to know how many elements are there? We tried this. So first of all, we will get we have a method size. So you can call the size method on this reference, and it prints number of elements out there. So 7, 8, whatever comes up. Then if you want to print all the elements added in that collection, you can just print the reference and it will work. So if I run this code, so number of elements in this list is 9, and these are the elements. But we are getting this yellow warning. So what are these? Let's hover the mouse and see. So Eclipse is giving this warning. It says ArrayList is a raw type. References to generic type should be parameterized. So you should tell this in advance. The E is the advanced part, you can say kind of a parameter, or we call that generic type, generic. So you have to tell in advance that what kind of collection you're going to create. So it will remove lots of overhead which you will face on when you're writing or when you're actually executing your code, or at simple terms, at runtime. So at runtime, it reduces lots of overhead of checking what's the type of the collection, because we are already giving it at front. So let's copy this example. I'm going to create one more class, ArrayList tester 4. Then let's get rid of all this part. So when you are going to create array list, what you have to do, you have to tell this in advance that this array list will hold only, let's say, integer type. So we have lots of wrapper classes in core Java library. So that's how we write. So what we just did here, we used generic type, that is integer. So we have multiple classes out there in Java library. So that is what do you call that, wrapper classes. Wrapper classes in Java. So that's homework. Try this out and check what are wrapper classes. Tomorrow we will check. So wrapper classes in Java. So one of the class which I already used, it's integer. So what we can do, whenever we are going to create any collection, tell this in advance that I am going to insert only integer in array list. So in future, when this code is executing, you don't have to check every time. Otherwise, think about this code. Here I have given integer, then string, then boolean, then float. I mean, random types are there. So when we are trying to process this collection or want to, let's say, call some methods on these types, so that might end up with some exceptions, because on string I can call some method, let's say length, or I can use some indexes, but that's not possible with the boolean types, not possible with the float types, even with the null. Here if I try to do this, I'll get some null pointers. So this might end up with some runtime exceptions, which is not feasible when you're working in the project. So one good solution they means the developers who wrote this whole APIs for us, they said, okay, if this is the case, so do one thing, don't write this code. And if you do, we will give a warning from the compiler. It will give you that ArrayList is a raw type. So convert it to generic type. And that's good. Now you can see no yellow marking. Now just add elements. So I can add elements now. Some random numbers I'm going to give, random integer values. Okay, so I just give random numbers and no yellow marking. So it's good. Now compiler understands that the collection you have created, it is of integer type, or it can take only integers. If you try to pass something else, let's say I'm trying to do this, I'll get a error this time. Not a warning, even the error. Right away we'll get the error. It says the method add integer in the type ArrayList integer is not applicable for the arguments string. So in the argument you cannot pass, you're not supposed to pass string. It only takes integer. Okay, so that's one compile time error you will get. So nothing will go at the runtime bus. And if you run this code, so number of elements 5, and these are things. So we just remove that warning, or we use some generic collection code. Okay. Let's say save to. Okay. Then now we can go back to linked list, because now onwards we will always use generic types. So we're talking about linked hash set. So it's a child of it, child of hash set class, and of course child of set interface. There it is. So we're talking about this one, linked hash set. Okay, so everything is same. Let's try to create this example. So new Java class, I'll say linked hash set tester. Okay, that's my class name. Then method main linked has set. And here I'll say I want to create integer types. It's not integer, you can pass string as well. So for now I'm creating integer type. And I'll say, because it's a collection of integers, I'll call this integers. Then equals, then new, LinkedHashSet, done. So object creation is done. Now in this object, we will add multiple elements or objects, or only of integer type. So let me give some random numbers. I'll keep it till or between 1 to 10. So 5, 1, 9, 10, 2. Okay. Now let's print them. And you guys will see some good output from this is out integers. So I'm just printing the reference. And if I run this code, run as application. Okay, check the output. It is giving 5, 1, 9, 10, 2. Okay, so what just happened here? It is bit different what we saw in HashSet. In HashSet, if I go back, this is what we used in HashSet. So the difference is here we give 5, 1, 9, 10, 2. We are getting the same format 5, 1, 9, 10, 2. But if we talk about HashSet, we give 1, 2, 10, then null. Okay, let's run this code and see the difference. We are getting something different. It's not even a sequence. It prints null, then 1 and 2, and then instead of 10, it is printing 211, then 500, then 21 and 10. So there's no sequence or no order happening here. But with LinkedHashSet, it's possible. If you are using LinkedHashSet, so it maintains order. Let's check whether it is mentioned in document or not. Yeah, it is mentioned. It says hash table and linked list implementation of the set interface with predictable iteration order. So it mentions here clearly that you can easily predict what would be the order here because it maintains linked list here. Linked list follows that order behavior. So the way you add element inside LinkedHashSet, you will get them in the same sequence. Something similar what we saw in array list. But HashSet is different. It is totally you cannot predict it actually. Totally random numbers will come when you run or print the elements. What else we can get from document? Yeah, this is important in terms of its internal behavior, like how it is implemented. So this is based on doubly linked list. If you guys have done data structure, so might have heard this term linked list and doubly linked list. So LinkedHashSet maintains a doubly linked list running through all of its entries. Entries means the element we are inserting. Entries or elements or objects, whatever term is clear to you guys. So whenever you insert any element, that element goes in a doubly linked list manner. But definitely, since everything is abstracted and we are using Java framework or collection framework, not Java framework, collection framework we are using, so everything is there, built-in solution is there. You don't have to only do something or write some extra code. Just use the same way. Just call add method, and this add method is implemented that way. So internally, every element 519 goes in a doubly linked list manner, and that's part of data structure. Okay, this linked list defines the iteration ordering that we already know, which is the order in which elements were inserted into the set. That is, insertion order is maintained. We already saw that from the example. There it is. Same point. Let's pick that as well. Saving some time. What else we can find? Note that insertion order is not affected if an element is reinserted into the set, because we know it doesn't allow duplicate element. If you do that, still it will be only one when you output or when you try to print it. So it's just a continuation of that, and by reading this we can clearly understand, because set has a behavior, it doesn't allow duplicate elements. So child also follow the same concept. If I again try to add 5, which is already inserted there, just one 5 is there. So it doesn't matter how many times you give it. If you run this code, 5 will be only one time, and at top is there, so it's there. It won't add 5 at the bottom. These will be ignored when they actually goes in a double linked list or doubly linked list. Okay, so this is clear, and this is about duplicate. So let's take this again to the paint image. So we saw one more class from that collection framework hierarchy, and this is the output. Okay, so this is done. Okay, next class from this list is TreeSet. So before reaching TreeSet, we have this interface, SortedSet. So let's talk about this. And okay, let me start with the name first. So the name clearly says SortedSet. So something must be sorted. And in this whole scenario, only one thing is there which can be sorted, that is elements. So that means whatever elements we will get, they must be in sorted way. That means in order. Some natural ordering we call that. So we will get elements in a natural order. So let's talk about document first. SortedSet is here. Let's search, otherwise I'll sorted. Not here. Maybe set. There it is, SortedSet. Okay, so let's talk about first of all its class signature, or the way it looks like. So it says public interface SortedSet, that generic type, then extends set interface. Yeah, it's clear from the document that SortedSet actually extends set interface, and set interface extends collection. So this is clear, fine. What else documentation says? A set that further provides a total ordering on its element. So here it is talking about order, that sequence basically. So it maintains total ordering, that you will get element in a sequential way. That's great. And the elements that are ordered using their natural ordering. Okay, so natural ordering means if we talk about alphabets, so they goes like A, B, C, D. If we talk about numbers, so they goes in a 1, 2, 3 sequence. So I give a sequence example here. So like A, comma B, comma C, comma D, dot 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 till Z. If we talk about number, so 1, comma 2, comma 3, and so on. So this is natural ordering. So it maintains that. It means SortedSet maintains that. So if you add any element inside it, so it will maintain that natural ordering. Okay, anything else? Okay, the set editor will traverse the set in ascending element order. Leave it. This will confuse you. Leave it. So the only focus you should be on that it maintains order, and that's it about it. SortedSet is just giving a behavior, but the thing is, this is an interface, so you cannot create its instance. So we have to go one level down to work with the class, because that's where we can create the object or instance of a class. So let's talk about TreeSet first, then we will write an example. So next thing in the image is TreeSet. That's a class, and SortedSet was interface. Okay. Okay, so going back to the document, this is based on actually red and black tree. Let's see what documentation says. First thing, you should know the class signature. How many class, not how many interface it extends, and which class it extends, and how many interface it implements, not extend, implements. Okay, so it says public class TreeSet, and it extends abstract set class and implements three interfaces: navigable set, clonable, and serializable. So these are three different interfaces part of Java library. And if we talk about its hierarchy, so again at the top you will find that object class is there. Object class is there, then its child is abstract collection, then its child is abstract set, and finally we are inside TreeSet class. So that's its hierarchy, the inheritance basically. Okay, anything else from the document? Okay, this again because it is implementing sorted set, so this is already there. So elements are ordered in their natural ordering. So that's obvious because it's a child of sorted set. So definitely it behave in the same order. It actually inherit that functionality. And this is some internal behavior. Usually it is asked in interviews that what kind of uh, time cost it has, like time complexity, how much time it takes to process something, or if you want to perform any operation. So what's the time consumption? So that's what it says. That's log n time. Okay, anything else? Um, okay, leave that thing. That's fine. We will focus on that our elements will be sorted. So let's write the code. Again, I'll keep it simple like we did earlier. So I'm going to create a new class. So right click on the package, then new and Java class, TreeSet tester. That's my testing class. Here I'll create a main method. That's our entry point. And then I'll create instance of TreeSet class. TreeSet. Again, I'll take integer type here. Integers equal new TreeSet. Then let's insert some elements. So integer dot add. Again, some random numbers. 5. Let's say 10, 1, 9, 3. Okay. Now let's print the elements. So how to print it? Simply say sysout, control space, select, and pass the object reference or the collection reference. So integers I'm passing. Now let's see the output. So right click on empty space, run as Java application. And you guys can see now we are getting elements in the same sequence 1, 3, 5, 9, 10. Okay, it's working great. So we are getting elements in a total order. Okay, what if we are using string? Let's test that as well. So sysout and just some kind of a border here and creating new collection. So yes, it's possible. TreeSet. This time I'm passing string like we did in integers. So now I'm going to create a new collection of string type. Let's say strings equal new TreeSet. I'll say strings dot add, and just for simplicity I'm just keeping only one character within double quotes like ABCD something. So I'll say W random character. Let's say E X A H. Okay, some random characters or alphabets. Let's test out this as well. Like, does it works? Will we get sequence or not? String, not this one. Strings. Okay, let's see the output. Yes, it's coming in the same sequence A, E, H, W, X. So it doesn't matter whether you are dealing with integers or alphabets, we will get elements in a ordered way or a sequential way. That is natural ordering. This is about we actually covered TreeSet or SortedSet. That's it. So why we are doing this way or why we are going through every single class? Because when we work in projects, so requirement could be the same way that I want some sorted elements. When you process the collection, I want elements in a say ordered way. So maybe you want to return this whole collection to a UI. So you don't want to process that in UI. You want everything from the backend, everything sorted. Just do that stuff. So you have to pick which collection class you have to use for this collection type. So that's the requirement. Go for TreeSet. So you will get everything sorted. Okay, this is it, and this is the output. Okay, and if we check this hierarchy, so we are almost done with the left section. Left section means all the child or subchild of collection interface. This is a different hierarchy. You can see it is not connected with any of the class directly, though it is using some of the classes directly, indirectly, but not actively. It says that I am extending or inheriting that or this. But yeah, it uses classes when we see the classes or their working methods. There we will see that these HashMap or TreeMap are using some method which is a part of interfaces we saw earlier of the collection interface. But before starting with map, I want to do something else. Then we'll jump to map. Okay. So going back to array list example, array tester 5. Let's close other files, close others. Okay, so this is example, simple example where I have a list of integers, adding the elements, not record this, and I'm printing them. So run as application. So this is default behavior of array list, and it prints the element the way you have inserted. So it maintains insertion order. So 1 45 789, 1 45 789. So yeah, it maintains that insertion order. The way you had it, same you will get it. Okay, clear. Now, what if you want them in a sequential way? This is fine, but I want array list to return element in a sorted way, right? This is also possible. Then how to do that? So it's possible by using one of the class which is a part of this collection framework. So let's see it is mentioned here. Okay, let's search it again. So it is collections java doc. So there is a Java class name is collections. So there are three terms. So don't get confused. Let's write them here. So the very first thing we learned was collection framework. This is the first term we saw, collection framework. Okay. There's an N missing. Then we saw there is a parent class. Its name is collection, and this is actually a interface. It's an interface. Now we are looking into one class whose name is collections. This is a Java class, and mostly it is known as utility class. So if you want some feature, some functionality, inbuilt function, ready-made functionality, so you can use this collections class. So collection framework is different, collection is an interface, and collections is a utility class. So that's its syntax. It clearly states that it extends object class. Usually this is not kind of common to see certain classes explicitly saying extends object, but yeah, it does. We remove this. So we saw similar terminologies. Okay, so why we are talking about this class? Because this class provides lots of methods which are really important in our day-to-day programming within collection framework. So what does documentation says? This class consists exclusively of all static methods that operate on or return collection. So all methods present inside this collections class are static. Okay, let's do one thing to move it here, and then it's fine. Okay, so we're talking about utility class. So it provides lots of static methods. Okay, great. What else? It contains polymorphic algos that operates on collection wrappers, which returns a new collection backed by a specified collection, and few other odds and let's leave it this is fine till here. Okay, so that's also great. So definitely we don't need to like look into all methods, but I'm just why I'm including this in session. So if in future if we use something, you guys have idea. Okay, so we saw something in our core Java and we are using it now in our project. Okay, so one famous method or most used method from the collections class is sort. So what we saw earlier when we are dealing with array list, one good thing is it maintains insertion order. But what if I want sorting as well? I don't want to use TreeSet, let's say. There is no, or maybe the managers or the senior guys saying, okay, TreeSet uses lots of memory and do lots of complex program thing behind the scene. So let's not use it. Array list is quite simple. Use it. But yeah, make sure that when you return collection, that should be in sorted way. So how you are doing that? Because TreeSet, we just saw TreeSet works good and it returns elements in a sorted way. So how to do that? We can use collections class. So collections dot, and there's a method sort, and it says give me the collection name or reference al. That's it. You just have to do this collections dot sort. So I'll print it this way, before and after. I'll say before sort method. Okay, and then that will be after sort. Copy it, paste it. It's after sort method. Okay, so let's run this code. On empty space, right click, run as application, and you guys can see now we are getting element sorted. So before sort it was same, insertion order is maintained. After calling sort method, we haven't used that variable anywhere, we just call that method, that's it. So it internally sort them and reassign all the sorted elements to the same variable. So we haven't reassigned it some other variable, no, not required. Just call the sort method, pass the reference, and that's it. So it internally sort elements, and whatever elements get sorted, they get reassigned back to the same variable al, and I just printed them. So this is how you can use some methods which are present in collections class. I'll give you an idea how many methods are there. So if you're interested, you can try out this class. Not coming good. Okay, and this is the output before and after. Okay, so this is also done. Okay, if we talk about the method it has, so if I scroll down, we can see method summary, and it has, you can see the scroll right side, see the scroll. So lots of methods are here. Like if you have a collection and you want to fetch maximum number, so you can also fetch that which element is maximum. You can also fetch minimum element. You can replace, you can even reverse the list. Yep, let me show you this method. This is interesting. Maybe you have to write a big logic to reverse a collection, but if you want to reverse it, simply call the reverse function. So let's say collections dot reverse and pass that al. Just a second, guys. Okay, so we just need to call this array collections dot reverse, and if everything goes fine, we should see that collection is in reverse order. So let's print this again. We cross check whether it returns or what. Okay, it's fine, great. So let's see this, and going to on, it's not sort, reversed collection. Okay, run application and check out, guys. So we are getting reverse element without doing or writing any logic by our end. We are using, or actually we are reversing the whole collection. It could be 5 elements or 500 or 5 million. Yeah, 5 million will take time, but definitely elements will get reversed. And we never know what could be the business requirement or client's requirement, because the UI page might need some sorting order. So this is also possible. Just call this reverse and it will be done. Okay, so likewise we have other functionalities that can be also implemented easily in this whole implementation. So now I can say the left section, which are actually child or subchild of collection interface, are done. Now we'll talk about this map section. Okay. Next in our list is map interface. Okay, so we have map as a parent interface, and it has not many but some classes I mentioned. Again, there are lots of other classes present inside in the map or map as a parent class. So but I picked only some required or say mostly used classes. Okay, so let's start with that. So again, for map deals in keys and values or key value pair. So map is also interface. It works with key value pair. That's one big difference between having collection as a parent class or having map as a parent class, because collection does not works in key value but map does. So if you have a key value thing and you want to use it, so map is one good thing. And believe me guys, map is mostly used class or interface in real-time projects. You will hardly see any project without map or array list. So these are certain classes which are frequently using. Okay, so let's see its documentation, then we will get back to the example. Since it's a map interface, so we need to search map somewhere if we get, otherwise we'll Google it. We get it here, map is here. So let's talk about its signature first. So this is how it looks, public interface map. And now instead of having one generic type, it has two, k for key, v for value. So earlier we were using this kind of syntax, array list, and just we used integer. But when we use map, that means we have to use two wrapper types. Okay, but we will see how to do that. Apart from it, what as it says the documentation, click. So an object that maps keys to values. A map cannot contain duplicate keys. Each key can be mapped to at most one value. Yeah, that's obvious. If you're working with keys, so key are supposed to be unique. Okay, so I'll put it in two different statements. One is an object that maps key to value. A map cannot contain duplicate keys, and each key can map to at most one value. Okay. Okay. This is something which you should know. There was a class dictionary. Okay, but nowadays it is obsolete. So it's no more in usage. But yeah, for you can say history purpose, that when this class or interface was introduced. So earlier there was a class dictionary, and that class got removed from the API, or it's going to be removed in future versions, and map class or interface was introduced. Okay, what else? And okay, I'll take these points later. So this is just overview, like how your map interface looks like. But this is not all, because we have to talk about methods as well. Without method, you cannot understand the behavior or what it, like how it works internally if you want to do that. So methods are must. We did the same with collection parent class. Same thing we have to do with map interface. So let's see what method it provides. So definitely it's different what we saw in collection. So if I scroll down, we have a list of method. So clear is same. To clear all the collection, you can use clear method. Not this way. Let's use the signature wise. So public void clear, that way. So we have void clear, done. What else? Compute leaf, this leaf contains key. Yes, we can use this one. Okay, not this way. We will pick boolean, that this is its return type. The boolean, it returns whether it has that key or not. Going up, contains key. Likewise, we have contains value. Then one more method is there. Just a second. Scroll. Okay. Next is get. If you want to get one particular value, so you have to give a key. So give the key in argument and you will get the value, v for value. Then put is important because this is the method we are going to use to add into the collection. In collection framework or in child of collection interface, it was add method. Here we don't have add method, we have put method. Put needs key and a value. So key will get assigned to that particular value we are providing. So we will use put instead of add method. Remove differently. If you want to remove something, so you needed a key. So give the key and that particular value will be removed, and it will also return the same value that what was removed, it will return it. Put or leave, clear, no key set. Okay, for now I'll just keep it aside. Later we'll discuss about it. So one method is key set. Next will be values, hyphen values, and one more method is there, entry set. Okay. So these are three different methods for traversing purpose, for traversing, for iterating, for scanning elements one by one. So that's what traversing means. Traversing, iterating, or reaching out to every element in a sequential order. I guess that's it. Other methods are just fine, not required at all. And this is good method, but it is default. Okay, I'll leave it for now. Okay, that's it. So for basic purpose, we would be needing these things. So put will add the method, remove will remove it. If you want to get it, you want to want to verify whether that key is present or not, whether this value is present or not, by using contains key and contains value method. Just a second, guys. Okay, so again there's a big constraint to test this method because map is an interface. With interface you cannot create instance, so that's the constraint. But now we have a idea how map works and what kind of method it has, and definitely we can test all these methods to a concrete implementation. So in our case it's HashMap, which implements map interface. So our next class is HashMap. Let's scroll up. HashMap is here. Okay, so this is the class signature. Let's create new paint image. So it's HashMap and this is a class, and this is its class signature. So it says public class HashMap key value, then it extends one interface, sorry, extends one class, that is abstract map, and then it implements map interface, clonable and serializable. Okay, that's fine. And this is its hierarchy, in inheritance hierarchy, I would say. It goes with object, then abstract map, and then this goes on. Okay, so we have object class at the top, then child is abstract map, and right away we will get hash map. Okay, so it is similar to what we saw earlier, like hash set, it is hash map. So again because it says hash, that means it implements that algorithm hash table. So hash table based implementation of the map interface. So there's one data structure known as hash table. So this class is based on the same algorithm hash table. Okay, what else it says? This implementation provides all of the optional map operations and permits null values and the null key as well. So yes, you can pass null key and null value as well. So your key could be null, your value could be null. It is permissible. Okay, so that's fine. Let's just put in one line. Okay. Okay, there's one big difference between hash map class and a hash table class. I'm talking about these classes. Hash table is one class and hash map is one class. So both are child of map interface. So the difference is the synchronization. It means multi-threading. So hash map class is roughly equivalent to hash table, except that hash map is synchronized and it permits null. Hash table doesn't do that. Okay. So hash map class is roughly equivalent to this hash map, except it is unsynchronized. It means build multi-threads. Multiple thread will be better. So if multiple threads are trying to read or write any operation on it, so they will get failed and we will get some um, random output. What we're expecting, we won't get that. But hash table is synchronized, all the methods are synchronized. So they are designed that way that if multiple threads are working on hash table, you will get desired output. But not in a case of HashMap. So that's one biggest difference. And hash table does not allow null values, but HashMap does. We already saw that it permits null values and null key. Okay, so that's one uh, high level theory of HashMap class. And now we have a concrete implementation. So whatever methods we saw in map interface, definitely because of this hierarchy, those methods get inherited to HashMap. So we can use it. So let's create one more class. Same package, the new class HashMap tester. There it is. Main method and HashMap. Let's import from util package, and now it needs key and value, right? So what I'll do, I will treat integer as my key type and value as string type. Up to you guys, you can pick anything, it's not fixed. You can pick anything. Then new hash map. Now I can add element inside it. So to add element, I listed out some methods, not all, but they are sufficient to work with basic example. So put is a method which can help us to add element in that collection. So I'll say hash map dot put. Now it is giving two options, one for key and one for value. So I'll say one is a key and a is a value of it. Likewise, let me add some more things. So see, I'm just giving in sequence. So looks good. 2, 3, 4, and 5. So I just inserted 5 elements inside this collection type. How to print it? Simple enough. Just sys out and pass the reference, the collection reference, that is HashMap with small h. Okay, and if I run this code, we will get elements. So that's how it prints. By default, it prints 1 equals to A, 2 equals to B, 3C, 4D, and 5E. So that's how it works, guys, when you are dealing with key value pairs. Let's create new paint. This is the code. Copy it. And then we have this. Okay, so we have this thing as output, and that's what works. So HashMap is done. Every class we are talking about in this image, it's about dealing with and understanding the functionality. Every class has their own purpose, their features, and as per requirement, we can use them. So that's why we are picking one class at a time and learning or understanding its functionality. Next class we have to understand, that is TreeMap. So to understand actually TreeMap, we have to check SortedMap. And yes, SortedMap is similar to SortedSet. So sorted means things will be in ordered, and TreeMap will definitely work as in a key value pair, but it also gives you ordering. So let's start with SortedMap first. So one more functionality we are getting here. Let's see that. So we are talking about SortedMap. SortedMap. This is an interface. Cool. Let's go back to documentation page. SortedSet map. Can we get it here? Might be on map page we get. We're already on map page. Yeah, there it is, sorted map. Okay, so that's its signature. class signature, public interface sorted map, key value, and it extends map interface. And yeah, that's obvious. We already saw this in an image, that diagram. It clearly says that sorted map extends map interface. Okay, fine. What else? This is a map that further provides a total ordering on its keys. Okay, guys. So when we are talking about ordering, because we have keys and values, so you have to tell this in advance that where you will get that ordering, either on keys or values. So here it clearly says it provides total ordering on its keys. So keys will be in order. So don't expect that you will get anything, but by default it provides ordering on keys. Okay, great. The map is ordered according to natural ordering of its keys. Fine. Yeah, that's the extension of it. I can put it here. Anything else? Okay, leave it. That will confuse you. Okay, so one simple statement that you will get sorting element, sorted behavior through this interface. Again, we don't have any extra method. It's just a functionality which is added by SortedMap. And since it's an interface, you cannot write any example on it. So you have to go one level down to its concrete implementation class, that is TreeMap. So let's go back to the documentation page. TreeMap is here. Okay, so now we are talking about TreeMap class. So this is similar to TreeSet, so I don't have to explain much about it. TreeMap class we are talking about, and this is it. Okay, so this is here a red black tree based navigable map implementation. So there is a data structure name is red black tree. So there's a data structure name is red black tree. We also call this arbitrary, and this class is based on that algo, and it is implementing all the methods as per its functionality. The map is sorted according to its natural ordering of its keys again. So that's a default behavior we get. So you don't have to do much, just call this class object and print it, and you will get all the elements sorted on its keys. Okay, this is something, some, you can say, internal functionality or the behavior that this implementation provides guaranteed log and time cost for its contains key, get put and remove operations. Algos are adaptation of this in the Corman listener reverse introduction of algos. So this is they mention that this class is based on that adaptation or arbitrary. So these are guys who wrote this, you can say, algo, Corman, Learson and reversed. Okay, so if this class ready, now we can write its example to see that functionality. Good thing is, since we are learning Java language, so we don't need to worry about how that algo is written. No need, because that's the reason we are using the framework. You don't have to write this logic, but yeah, you have to work on some client requirements. They will say it, okay, and you have to figure out, okay, so I know one class in collection framework which can help this without writing extra lines of code. One line and it's good enough. Okay, so going to create new class. It will be TreeMap tester. Done. Let's create main method. Done. Then we'll start TreeMap needs key value. So again, I'll keep it that way, same integer as a key and value as a string. Again, you can use it anything, it's not fixed. Then new TreeMap. Done. Then map dot put. This I'll give some random numbers. Okay, let me try this way. So 5 e, because if I sequence it, that will affect it. Okay, let's give 3, so I'll give it C. Let's give it 1, so it will be A. 4, it will be D. So I just jumbled them up, and 2 for B. Okay. So there's a reason why I give in a sequence way. So if when it comes up in output, so you guys understand. Now sys out. That's it. And how to sys out? Just print the reference of that collection. That is map here, or the object of reference in normal language you call this. And if I run this code, you can see it is coming in the same sequence: 1A, 2B, 3C, 4D, and 5E. So without writing any extra logic or code, if you want your collection, not actually collection, the map type collection in a sequential way, you can always go for this type. That will be working. Okay, so here it ends with all the classes we listed out. There are certain classes which I marked in a black color. So that's the homework. If you do that, that's good. If you cannot do that, let me know. If you have issue, we can resolve it together. So this is the end of collection framework classes we discussed. And tomorrow we will see either we can, if you have some doubt or concerns, we can resolve that first. Otherwise, I might pick new topic for our session. See guys, I'm not going to cover every single classes or methods. It's not required at all. I just want to give you an idea how collection framework works. So in future topics where we actually use frameworks like Hibernate or Spring Boot, there we will use all this functionality. So this is must to know. Otherwise, I can even start with the Ratley's Hibernate framework and Spring Boot and other high level technologies.